Welcome to this presentation by PenSpen. The subject today is constrained cost strategies for safe and efficient future pipeline operations. And today we'll be presenting some of our research into technologies which will enable this for pipeline operators in the future. There are many challenges to the oil and gas industry. Things are changing fairly quickly, but there is opportunity as well. It doesn't feel right somehow to talk just about the challenges as an introduction to a presentation. But the oil and gas industry does not typically do things without reason, does not make change without reason. And so we must identify the challenges first before we go any further. The recent fluctuations in oil and gas prices, particularly oil, are obviously a concern for industry. We can see recently, as everyone knows, oil and gas prices temporarily went negative. It's obviously very hard to make a profit on a product with a negative price. But really, this is a matter of perspective. Over what timescale are we looking? If we look back a little further, we can see that oil prices typically is a lot higher, but we can also see that the variability in price in 2007, 2014, 2020, when new engineers or potential new engineers are looking to join our industry, how do we persuade these engineers that it's a good industry to be in? It's a stable industry. And if we look back further even, we can see that actually oil price for a considerable period of time was very stable. And it's only recently that these sudden peaks and troughs in price are really occurring. What can we do as an industry to ensure that there is a stable price, whatever that price may be? And how do we assure young engineers and thinking about entering the industry that it's a good industry to be in? Aging infrastructure is something else that can be of concern to industry. For example, in the UK continental shelf, there was a lot of construction in the 1970s and 1980s. A lot of that infrastructure still exists in place and is in use. And I'm sure everyone's aware of the bathtub diagram. We're obviously a long way past early failure. And in all likelihood, we're a long way down the usage of useful life. And we're approaching the area where infrastructure is wearing out and requires more care, better engineering to ensure an appropriate level of safety. And one way of appreciating the problems that are being stored up for future is to look at the amount of pipeline above 40 or 50 years old. In this example, 55% of pipeline is more than 40 years old. We are very much approaching the era of 100-year-old pipelines. This will become more and more common. A 100-year-old pipeline will not necessarily fail because it's 100 years old, but it will certainly take more care to keep it in good condition. Increasing regulation and regulatory burden is common globally. For example, it's not acceptable to operate a pipeline less safely than in previous years. Regulation will probably require us to operate more safely in future years, even though the asset is aging. As another example, the UK continental shelf and the MER strategy by Oil and Gas Authority. Larger fields within the UK continental shelf are commonly either known about, being exploited, or have been exploited. We're seeing a transition to exploitation of smaller hydrocarbon pools, commonly by asset-led exploitation and exploration. And so MER seems to have recognized this and legislated for it. And so the MER strategy obliges all pipeline operators to look after their pipelines, irrespective of who's actually going to use them in future. The obligation is to keep the pipelines in good condition to maximize economic recovery from a geographical area. And the key point with this smaller exploitation of smaller pools of hydrocarbons is that the availability of export infrastructure, such as pipelines, is a key factor in whether recovery is economic or not. We can only expect this type of regulation to become more common in future. Infrastructure availability is a key factor in many mature fields. For example, UK continental shelf, as well as all of the smaller pipelines, infield pipelines, there are many transmission pipelines. We must keep these in good condition, otherwise large areas of the UK continental shelf, North Sea basin, will be uneconomic to produce from. And this is an example from the Oil and Gas Authority. There are a large number of hydrocarbon pools which can be exploited, provided infrastructure remains available. But there are other things in play. For example, the change to renewable energy. As it turns out, electricity is terrible for energy storage. Flammable fuels, flammable liquids, gases, are actually pretty good at storing energy. And this is being looked into with hydrogen deployments, hydrogen storage. Can we use pipelines on a day-to-day basis with line pack for gas pipelines? Can we do the same with hydrogen and treat the transmission pipelines as an energy storage facility? This is being looked into. And both these reports actually are very interesting and well worth a read. And this is even before we look at carbon capture and storage. How do we get this out to depleted fields? Pipelines will be required in the future, whether for hydrocarbons or not. Personally, I believe there will be a decoupling of pipeline industry from the oil and gas industry over time. This will be slow to start with, but it will increase as pipeline is required for other usages. And so these factors can be summed up as the industry quadrilemma. We have aging assets, commonly at or beyond their design life. But remember, they don't fail because they're old. We can't have an increased danger to public or to workers, and therefore increased risk of failure must be managed. Hydrocarbon resources in many areas are becoming depleted, but it's not just the hydrocarbons. We need the people. If we can't attract people into industry, the right people, we won't be able to function as an industry. And at the same time, we have more legislation, stricter legislation which affects our industry in a way that it didn't before. And we have to deal with all that and ensure we comply with it. And at the same time, the finances of various projects will change. They will change depending on expected product price over a project lifetime, expected export infrastructure availability. And how do we adapt to this change? There are undoubtedly challenges for our industry, but actually there's a lot of opportunity as well. Change can be painful, but equally it can be a force for good. I'm an optimist, so hopefully I'll be able to share some of my optimism throughout the rest of the presentation. One of the things that I find gives me real cause for optimism is digitalisation, and in particular, Industry 4.0. And so looking at the diagram, we can see Industry 2.0 typically would be the Excel sheets. Industry 3 would be computer programs. And Industry 4 is really the future. And commonly when people are talking about digitalisation, they're talking about a shift from Industry 2 to Industry 3. And there's real opportunity right now. Can we bypass that step from 2 till 3? Can we go directly from Industry 2 to Industry 4? And what can that do for our industry? What does it have to offer? And as a quick explanation, when I refer to Industry 4.0, I'm referring to Internet of Things, live data, smart operations, real-time optimization. And this includes, in some cases, machine learning, artificial intelligence. But we must be a little bit careful with these technologies. Quite commonly, we find it's better just to use better mathematics. Machine learning and artificial intelligence do have a place, but realistically, whenever we're developing internally at PenSpan, we do everything we can to avoid using artificial intelligence or machine learning. Commonly, there are just better ways of doing it with mathematics. One of the reasons that the shift to Industry 4.0 can be made possible really is the improvement in technology and in computing power. Take, for example, the price of data storage, processing power. These are all moving in favor of a data-driven society. And actually, Moore's law predicted that this increase would slow down. And for typical CPU processing, yes, it does. We're not quite at the period of home quantum computing yet. But in the meantime, GPU computing using a graphics card can defy Moore's law, at least for a short period. And so why think about a shift to Industry 4.0? As an industry, we're very conservative. We already know that we're 20 or 30 years behind other industries technologically. And the data already exists in many cases. SCADA data records live data, but we're not using it properly. If we were to get a fitness for service assessment performed by a consultancy, the data may be up to a year old. We may wait another month before the report comes back. And then we make a critical decision or potentially critical decision based on out-of-date data. Why are we not making these decisions based on data today? PenSpan believes that ultimately we will transition away from reports. In the short term, automated reporting will take over, and this can be done daily, weekly, monthly, whatever. But longer term, the sheer volume of data being processed and being delivered back to inform decisions will require a shift to dashboarding. We believe it will happen in the near term, but the reports will be retained, at least for the medium term. And to give an example of an Industry 4.0 type of assessment flow, what would the ideal technology solution look like? We have many various forms of data, perhaps multiple ILIs, in some cases not. Operations data, and this could be Internet of Things, it could be pressure, temperature, process control data, anything. Construction data, repair data, any other form of data. Currently, this is all typically aligned by hand. It's very time consuming. And this all needs to be automated. The general philosophy has to be automate everything. Once we have that data together, machine readable, aligned, we can do assessments. And it doesn't really matter how many assessments we do. If we've made the shift to GPU computing, multi-threaded computing, they can run in parallel. It really doesn't matter how many assessments you do. And automated reporting. Yes, we can pay someone to write a report, but why do so in many cases when the report can be written automatically? Engineers will be able to spend more time, engineers of the future, will be able to spend more time on making the decisions that matter, not on just moving data around and making data usable for an Excel sheet or for a computer program. Everything will be automated. And ultimately, if we automate to the extent where we generate a report every 30 seconds, which is about where we're at the minute in PenSpan, nobody's going to read a new report every 30 seconds. But it does open the possibility for live dashboarding. So we can see what's going on with the pipeline right now. What are the threats to safety? What's causing me a risk? What do I have to do to optimize my inspection strategy, for example? And it's worth remembering a little bit about why we do this. And I've said immediate results. Take, for example, if you want to ask a question, any question of the internet, we can type it in on our phone, whether we be at bed, in bed at home, at work, anywhere. It doesn't really matter. We get an answer back in a fraction of a second. Why do we accept waiting for a month or more for a report? It's not necessary. It's not acceptable. And to the young engineers coming into industry, it won't be acceptable to them either, even if we accept it now. And so future pipeline integrity analysis must be fast, preferably immediate. And one of the things we are going to have to think about is how do we return this volume of data in a coherent format? How do we allow the engineer to make sense of it? Implementation of new technology is not necessarily easy or simple. If it was easy, it would be done already. There are challenges, we must recognize that. The question really is how do we deal with those challenges in a way that makes the transition as pain-free as possible. And so there are roadblocks to implementation of digital technologies. And the ultimate aim of any new technology must be to achieve operation of pipelines with zero failure. And if we can achieve that, we're in a good place. Digitalization within industry is fairly well recognized and in many companies well underway. So actually, a lot of the challenges are already being addressed. And a lot of those challenges that have been addressed pave the way for an Industry 4.0 philosophy. But there are a couple of extra problems, and so we'll talk a little bit about those. And as a recap, in general, for digitalization, there are problems with proprietary software. Software doesn't typically talk very well to each other. IT systems don't necessarily work well together at all. And data transfer formats, yes, they exist, but in common usage, there are problems. Is a percent 0 to 1, or is it 0 to 100? And we see all sorts of different data formats, interpretations of data formats being submitted to PenSpan. And there are difficulties in free flow of data in between stakeholders. Companies are protective of their data, and in many cases, rightfully so. But at what point does that need to change? What point does the data need to start flowing more freely? And all of these factors combine really to aid the formation of data silos, where the left hand doesn't know what the right hand's doing, even within the same company sometimes. One of the benefits of a full digitalization implementation in any company has to be to allow the company to work better as a company. There are three main roadblocks identified for implementation of Industry 4.0. And the first and probably most important of these is the threat to data security. We must secure our data. We must do it already, irrespective of Industry 4.0. And this must be fairly central to the thinking behind what we're doing. A live, controlled data sharing framework. As an example, we previously have had a portable hard drive sent through the post. This is not suitable for Industry 4.0 and probably not suitable at all. We need to be able to transfer live data between operator, between inspection vendor, between engineering consultancy. And it needs to be done in a controlled way so the operator retains ownership of the data, retains ownership of the master data format. And when we say transfer data, on this slide I've said the flaws in data structure usage. Yes, there are data formats available, but commonly the way in which they're being used has problems. For example, is a percent 0 to 1 or is it 0 to 100? And we see both coming in data sets that are nominally compliant with the same data format. So either the data format is not strict enough, or the way it's being used is not correct. Either way, data needs to be machine readable. And ultimately, we've got to go back to data security. 5 or 10 years ago, it would be very difficult to sell somebody in the oil and gas industry on cloud infrastructure. But realistically, when we look at data security, the UK Ministry of Defence, US Department of Defence, and the CIA are all shifting to cloud architecture. And so we could reasonably believe that it's secure enough for our purposes as well. And this is a really big question. Who exactly is going to implement Industry 4.0? Yes, we will need robust project sponsors who understand digitalization, Industry 4.0, and their own company, and can drive a project forward within a company. We will need to gain buy-in from the ultimate decision makers in each company. A changeover project does have a cost, even if there's good return on investment, and that cost must be signed off. But really, who is actually doing this? And it's going to be the pipeline engineers who have the capacity to learn computer coding skills and to interact with computers as a digital native. And this is a less understood skills gap. Industry is very well aware of the primary skills gap, where competent people are leaving the industry at a quicker rate than new recruits are entering the industry and gaining competence through training and experience. This second skills gap does have the capacity to hurt company development in the future. We may have to go out and recruit from outside of our industry to gain the people with these skills within our industry. And it's worth reiterating, a computer will not replace an engineer. Highly competent pipeline engineers will be required. And actually, there'll be an obligation for them to be more competent, become more competent more quickly than existing. But the skills will be very similar and will overlap in many cases. Industry 4.0, of course, must have something to offer to the oil and gas industry. Otherwise, there's no point in adopting it. And so the next several slides will introduce some of the research we've been undertaking at Pennspan, and also what we believe in as a vision for future pipeline operations and integrity. One of the major enablers for Industry 4.0 will be digital native architecture, ultimately cloud architecture. Take, for example, normal processing power. This relies on us purchasing the correct hardware, enough hardware, recent enough hardware. Cloud processing does not suffer from this problem. If we want more processing power, we ramp it up instantly. There is no time taken to upgrade the hardware. There's no time taken to request upgrades from the IT department or for the corporate structure. And this will impact the way we pay for software as well. Historically, it's been common to take out a license, perhaps with upgrades, or perhaps for a fixed software product with no upgrades. And we would expect that this over time will change to be more in line with consumer software nowadays, which is tending towards subscription-based models. And in this way, we always have the best software, the most up-to-date software, all updates, new assessments. It's all there instantly. And it's included as part of the subscription. The ability to have scalable processing power as and when required will allow us to develop new assessments. And this is an example of an assessment which was developed within Pennspan for assessment of probability of failure for corrosion features with complex geometry. And typically, this just hasn't been possible. With normal CPU-based processing, this could take anywhere up to the region of 100,000 years for a very large feature. And in this case, by using GPU processing, we were able to reduce it down to about 3 hours. New assessments like this will be developed. The next 5 to 10 years of development of new assessments will be very interesting. And of course, when we go back to the general ethos of better mathematics over machine learning or artificial intelligence, we see similar jumps again. And this is a similar problem, but developed a little further. And it's actually been reduced from around about 3 hours down to around a quarter of a second. And this allows the live assessment, the Industry 4.0. If we can calculate probability of failure in that sort of time scale, we can do it on the fly. We can do it live. And it can drive live RBI. It can drive live decision making. When we start to look at the data that's already collected, live data, which can be used for Industry 4.0, we're looking for live or quasi-live data. ILI data, perhaps, is not so live. It only gets updated on a periodic basis. But other data sources do exist, which allow us to develop more targeted assessments. And a lot of this we actually gather already. Strain gauges, pressure monitoring, process monitoring, CP monitoring. We do this already. But there are other data sources which we can tie into, which actually do exist. We just don't use them, or not very commonly. LiDAR point clouds, weather forecasting and seismic monitoring. This can all feed into better pipeline safety on it, and we can monitor this on a live basis and ultimately start forecasting. And so realistically, from the Penspan point of view, the future of pipeline integrity will be driven by the shift to Industry 4.0 and the improvements that can bring to the decision-making process, the data available with which to make business critical and safety critical decisions. And we can use this data to either target lower probability of failure, reduce cost, optimization of expenditure, or a combination of all of these. And we can do this in a couple of different ways. For example, live fitness for service dashboard. If we have a known fixed point in time, for example, an ILI, and we know all the process parameters and other factors that could affect pipeline integrity or change of features following that ILI, and then we can start to predict live fitness for service. What is the fitness for service today? Not what was the fitness for service when the data was collected. And this can partially be enabled by real-time direct assessment. And actually, this is quite interesting. This can feed into a lot of different areas. Predictive analytics, live risk management dashboards, and live validation of inspection period extension strategies. This one is quite interesting, actually. So commonly when we look at optimizing an RBI strategy, it's in response to something like a reduction in the price of oil and can we defer an ILI inspection? And looking at this the year before the inspection starts, or is expected to start, is not an optimal way to treat this. A much better way would be start at year zero, the year following the previous ILI, and optimize the way we're operating the pipeline for the whole period to get to a desired inspection outcome. Industry 4.0 has so much to offer to the oil and gas industry, to the pipeline industry particularly, with aging assets, with constrained costs. The return on investment could be huge. And actually, feel free to email me or have a conversation. But for now, we'll move on to the summary. During research and development within Penspan, there are several important lessons learned, and which other companies may benefit from them. So I'll share them here. We see that technology is advancing faster than digital transformation within the oil and gas industry. A lot of companies are doing a lot of good work in digitalization of the industry, but it's not quick enough. We're not going fast enough. It's a conservative industry, yes, but we're so far behind. We need to make a bigger leap right now. Industry 4.0 can offer improved analysis in real time and reduce the need for wasted man hours. And this can actually partially solve the upcoming skills crisis. We can do more with less. Industry 4.0 has the capacity to optimize pipeline operations and ultimately to reduce overall cost of extraction without negatively impacting safety of the pipelines. And our industry right now has the opportunity to implement digitalization at an Industry 3.0 level and Industry 4.0 in a single step. The data structure and data sharing do require improvement. And one way to look at this, 30 years ago, 40 years ago perhaps, pipeline engineers could not be expected to understand the impact that even Excel or computer programs may have on how data is shared and stored. We don't have that excuse right now. We know the industry will change. The way we share data will change. How we store it will change in the future. I don't really want to have to sit down with a next generation pipeline engineer in 30 years' time and say, we knew we should have done something, but we didn't. And a key point here really is identify and develop key strategic partnerships, technology partnerships, partnerships with personnel within your own company. Identify the correct people. And we've got to be aware the oil and gas industry will be competing against other technology industries for the best candidates. And so the second skills gap really has the capacity to hinder what we're trying to do here. And digital change really, it is more likely to succeed in motivated companies. And whatever that motivation may be, identify it and then identify what a change to an Industry 4.0 strategy could do to help you. And a good way to start this is focus on return on investment. Take the easy wins. We can aim for the most complex system to start with in the future, but it's a lot simpler and a lot easier to prove a good return on investment by starting with something simple and then making it more complex. And so a roadmap to implementation of Industry 4.0. We do believe Industry 4.0 will happen anyway, but by planning for it properly, the relative pain can be reduced and the benefit can be improved. And ultimately, this is going to have to be pushed by operators. It is possible to implement digitalization right now, but we also need to look at the future. Is digitalization enough, or do we need Industry 4.0 as well? And we've got to remember, we're in the era of 100-year-old pipelines. The data we generate right now and store right now, the formats we're using today, they're going to be a problem for pipeline engineers of the future, perhaps 100 years in the future. And so we need to get this right. And so it's possible to specify a high-level roadmap on a way to implement Industry 4.0 within our industry. At a very high level, this would include things like identification of key stakeholders and a core group of committed project sponsors. And this is not just limited to a single company. There must be cooperation between many companies. We must have a clear, defined vision of future requirements. We're not implementing Industry 4.0 just for the operations of today. It's also for the operations of the future. And so we must examine how are we going to use this data in the future? What are the requirements for storage? Do we need to do something different to the way we're doing it now? There must be a review of the current state of data management practice and the way it's actually being used in industry. It's all good having a reasonable data format or structure, but if it's not being used appropriately within industry, then there is still a problem. There must be a clear value proposition. I believe there are benefits to implementation of Industry 4.0, but that needs to be clearly stated so that other companies can make an informed decision on whether to implement Industry 4.0 within their company as well. And we must provide support. How do we help other companies implement Industry 4.0 in their company? Yes, it is competitive. And I believe that companies that do not undertake an Industry 4.0 transition will be at a disadvantage. But we must make it easier for other companies. There must be a clear definition of specifications. And actually, this includes master data management as well. This will be driven by operators rather than consultancies. In terms of the whole roadmap, it would be perfectly possible for a singular consultancy to develop a data structure, a data sharing format, and all the ancillaries. But without operator buy-in, without operator support, it will go nowhere. This needs to be driven by a group of operators and pushed by a group of operators working together. And we need to look at the transition planning and how to implement it within a company. We're doing a lot of work internally at PenSpen on how we do this. And again, if anyone's interested in talking in further depth, please feel free to contact me. And we need some way of working out what have we achieved, well-defined KPIs. What is the return on investment? How can I justify further investment? And so in summary, we believe that the digitalisation and particularly Industry 4.0 have a lot to offer to continue safe pipeline operations, but there are likely to be some difficulties in implementation. Small-scale implementation less so, industry-wide more so. We believe that we mustn't just look at what's required right now, but we must also look to the future. In what ways do we believe technology will change in the future? How do we believe that the usage of pipelines will change? The pipelines that are expected to be decommissioned in the next 5-10 years, can they be recommissioned for hydrogen storage, carbon capture and storage? We need to think about this very, very deeply and identify the most cost-effective way to utilize infrastructure which already exists. And PenSpen believes that digitalization on a small scale, in a haphazard way, it's not sufficient to maintain the industry as a whole. And we need to sit down really as an industry and look at the future integrity demands, such as Industry 4.0, and we must consider that now. And this will require some degree of industry-wide cooperation and governance as well. And PenSpen are quite happy to be involved, but this really must be operator-driven. As responsible engineers, pipeline engineers, we must stop and think about the way in which we store and manage data and the way in which we use it today. The data we store and pass to future generations of pipeline engineers must be compatible with the way in which future engineers will use our data. Pipelines which are new today could quite conceivably still be in use in 100 years' time. And so the data we're generating and storing right now must be compatible in the way in which it'll be used in the future. And as with any transition, the people are the real asset, the key asset. And when we look at it, in a transition to Industry 4.0, the competency requirements will change for pipeline engineers. As an industry, we will need to be aware of this and support accordingly. And personally, I believe that will result in pipeline engineers, as they enter the industry, being expected to progress more quickly, become more competent more quickly, become more competent in digital technology. And some of these engineers will be digital native, and they will find this transition a lot simpler. And we must also identify the key people with the propensity for digital, and preferably the coding. It turns out it's incredibly difficult to explain pipeline engineering to a software engineer. It's far simpler to take a mechanical engineer or a pipeline engineer and teach them how to code. We just need to identify those key people and train them correctly. Thank you for listening. And for any further inquiries, please feel free to get in touch.